Okay, so now it's 2:30, so it's time for our class. Today I'm gonna starting with this graph. Okay, this is a graph that we talked last time. In this graph, it's showing the changing of the saving rate. Okay, as you can see, if I using the red color here, okay, this is the changing of the saving rate from very small S1. If the saving rate increasing, the investment and saving curve gonna shift up. You see, right? If the saving rate decreasing, okay, from the very small S1 to the very small S3, the investment and saving curve gonna shift down. Okay, as you can see, when the saving rate change, investment and saving curve gonna change. When investment and saving curve change, it means that the steady state point gonna be changed. So in this graph, the steady state point can be SS1, or it can be go up to SS2, or it can be going down to SS3. So normally you can control the steady state point if you can control the saving rate. Okay, you can control the steady state point if you can control saving rate. The steady state point can move along this curve. Okay, the steady state point can move along this curve, going up or going down. Okay, depend on the saving rate itself. Okay, this is what I want to show you here. Okay, so I can write down the conclusion here. If, okay, we can, okay, if we can control, okay, the saving rate, this guy, what I mean is we can control saving. If we can control saving rate, we can control saving per worker. Then we can control investment. Then investment is about buying the new capital, right? That is mean that we can control capital per worker. And in the end, we can control steady state point. Okay, so steady state point can move, okay, move up and down, okay, on the capital depreciation curve. So the next question is, since we can control the steady state point, the next question is, where is the best location, okay, for steady state point? Since we can control the steady state point, the question is, where is the best one? Okay, where is the best of the steady state point? Well, where is the location it should be? Okay, so let me drawing the graph for you. On the horizontal is small k, on the vertical is small y, small c, small I, small s, and delta small k. We have production function curve like this. Small y equal to function of small k. We have capital depreciation curve, delta k. If we can control the saving rate, okay, we can control the steady state point. So where is the best location for the steady state point? Okay, you may thinking that the best of the steady state point may be the point that you can have the maximum, okay, the maximum of the production or the maximum output. Okay, where is the maximum output? The maximum output is somewhere here on top. This is max y. Okay, the maximum of output per worker, y max. Okay, you may thinking that this is maybe the best of the steady state point. If you want the steady state point to be here, only thing you need to do is you need to control the saving rate of the people to be here. Investment per worker equal to saving per worker equal to saving rate multiplied by function of k. You just need to control the saving rate to be here. If you can control saving rate to be here, the steady state point is gonna be here, SS KWS. Okay, so then you can produce at maximum level. The yellow area here, this is Y max. And then your saving and investment is going to be here. Okay. Investment at the C set point equal to saving at the C set point. The green area and the less is going to be the consumption. Okay. The blue color. Okay. However, the point that you can produce maximum number of output is actually not the best. Okay, the point that your country can produce maximum output is actually not the best. Why? Let me show you here. If you want your country to produce maximum number of output, max Y, okay, maximum output per worker. If you want to produce a lot, what does it mean? It means that your country need to accumulate a lot of capital, small k, right? When your country need to accumulate a lot of capital, what does it mean? You need a lot of invest. Okay, you need to invest a lot. If you need to invest a lot, what does it mean? You need to save a lot. Okay. If people in your country need to save a lot, what does it mean? When you save more, okay, you need to sacrifice something, right? When you save more, you need to sacrifice your consumption. This is actually not good, okay? If your mom, your dad asking you to save a lot and consume less, are you happy about that? No, nobody happy about that. Okay, nobody happy if the government say that, hey, everyone, we need to save more. You have to consume less. You cannot buy expensive product. You cannot go to the very good restaurant. No, everyone have to eat mama instant noodle. Okay, in order to save more. Nobody like it. Okay, if you need to sacrifice consumption, you need to spend less. Everyone gonna be unhappy. You got it? So, as you can see from this graph, in order to produce at the maximum level, consumption is very small. Right? Consumption is very small and everyone gonna be unhappy. So the idea about to have maximum level of output is actually not good. Okay, not so good. Okay, this is not the purpose of the theory. Okay, the purpose of the theory is our goal is we want everyone in the economy to be happy, right? And you as a member of the society, you're going to be happy if you have money to buy something, right? Happiness comes from people going to be happy. Happiness comes from utility, right? We want everyone to have the maximum utility, and utility and happiness come from consumption. You got it? Okay, happiness comes from consumption. So I can write down the conclusion that the base of the steady state point is actually the point that everyone gonna have maximum consumption. So far so good? Okay, maximum consumption, and we're gonna call the steady state point that provide the maximum consumption as a Golden's Rule point. This is a name. Okay, Golden's Rule point, maximum consumption. So far so good? Okay. Then, if you focus on this one, this graph, okay, the consumption, okay, is actually when you save a lot, consumption is small, right? The gaps, the blue area, the blue highlight is very small, you see? Okay, very small. If you want to have a maximum consumption, where is that place? Let me showing you here. Drawing the graph. This is small k. This is small y, small c, small I, small s, and delta small k. we have production function curve, small y equal to function of small k. We have delta k. The area of the consumption, if you're looking at this one, the area of the consumption is actually the space between production function curve and capital depreciation. Okay, so the maximum consumption is going to be the place that, okay, the point that the space between production function and capital depreciation is largest. Okay, it's largest or biggest, which is going to be somewhere here. Okay, here, see that? This is the place that you're going to have maximum consumption. So if you know that the maximum consumption is here, the only thing that you need to do is control the saving rate to be here. If you can control the saving rate to be here, this is going to be the steady state point, which we call as the golden rule, G, KG, and YG. You got it? Okay. The yellow area here, this is the output per worker. Okay. YG. The green area here, this is investment per worker, IG, and saving per worker, SG. And the blue area is here, max C. Okay. Maximum consumption per worker. I can call it as EG. Okay. This is what we call the golden rule point. Okay, the steady state point that gives us the maximum consumption. Okay, is here. So how we can find the golden rule point? By using mathematics. Okay, how are we gonna find the golden rule point? By using mathematics. Let's drawing the graph again. This is small k, O, small y, small c, small I, small s, and delta small k. We have a production function curve. We have capital depreciation curve. Okay, the maximum consumption. Okay, the maximum consumption is gonna be the place that the gaps between production function curve and the capital depreciation curve is the largest. Okay, have the largest gap between two curves. It's gonna be somewhere here. Okay, by mathematic property. Okay, by mathematic property, the largest gap between two curves is gonna be the point that the slope of upper curve and the slope of lower curve should be equal. Okay, the slope should be equal. Okay, the slope of upper curve and the slope of lower curve is going to be equal. So this one is a property of mathematics. So if you want to find the maximum consumption, okay, you can find between, okay, you can find by find the slope of upper curve and the slope of lower curve. So maximum consumption is going to be the point that the slope of production function small y equal to function of small k equal to the slope of delta k. This is a mathematical property. Okay, so far so good. Okay, then we're gonna find the slope of both curves together. So we're gonna write down here golden rule. Golden rule point is going to be the steady state point that's going to give us maximum consumption per worker. Okay, the condition is very simple. The slope of upper curve, small y equal to function of small k, should be equal to the slope of lower curve, delta k. This is the condition for the golden rule. Okay. When I say slope, okay, the slope is actually come from the very simple mathematical formula. Okay, the slope is equal to delta vertical over delta horizontal. Okay, in this case, vertical can be y, can be c, can be s, can be delta k, and horizontal is going to be small k. So in this case, for the production function, the slope is going to be delta y over delta k. Okay. And then you just, y is, delta is just like a derivative, right? It's calculus. So this one is equal to delta y equal to function of k over k. And this one, we're going to call it as delta is like a changing, right? This one by the meaning is, if you have more capital per worker, how many output per worker you can produce more, which is, we talked about this before. This one equal to MP small k, marginal product of capital per worker. Okay, keep in mind. On the right hand side, we have the slope of delta k. Vertical is delta k, horizontal is k. This is like a derivative, right? Partial derivative of delta k respect to k. This one equal to just delta. See that? The slope of production function curve equal to MP small k. The slope of capital depreciation curve equal to delta. So the condition for the golden slope point is just MP small k equal to delta. Just that. This is the condition for the golden rule. So far so good. Any question here? Everyone was still okay, right? Easy. Okay, so I'm gonna give you some mathematical example. I'm gonna use the same information that we learned before when we calculating the steady set point together. I'm gonna bring it here. So this is mathematical example. The first information, I'm gonna use the case that we learned before. Small y equal to small y equal to square root of small k. Okay, so in the exam, I'm gonna give you the production function in the big letter equation. So you need to transform into the small letter, right? We did it together. So here, if I already have the small letter equation, small y equal to square root of small k. Okay, so this is information number one. Information number two, the saving rate equal to 0.3. Okay, saving rate equal to 0.3 means that normally people are going to save 30% of their income. Information number three, delta equal to 0.1. Okay, normally the capital gonna broken down 10%. Okay, this is, we did this one together. If you still remember, I'm gonna write it in the red color. What we did together is we use these three information to find the steady state point. We did it before. And the result that we get, k at the steady state point equal to 9, y at the steady state point equal to 3, consumption at the steady state point equal to 2.1, investment and saving equal to 0.9. This is what we did before. Okay. However, today is different because today we're gonna try to calculating for the golden rule point. Difference. I write down here. Today we want to find the golden rule point. I put in the bracket that the golden rule point is gonna be the steady state point that gives us the maximum consumption or max C. Okay, so when you're gonna find the golden rule point, you have to come up with the condition that we just solved before. Okay, the condition for the golden rule point is MP small k equal to delta. You need to come up with this guy. This is a condition for the golden rule, and you should know what is MP small k. MP small k, marginal product of capital per worker equal to delta y over delta k. Write down what is MP small k. Write down delta. You already know it. Delta is given. Okay, equal to 0.1. Write down. That's it. Okay. And what is y? We use information number one. Y is square root of k over delta k. Delta is just like a derivative, right? So this one is a partial derivative. K power by 1/2 respect to k equal to 0.1. Then you can do the calculus, high school mathematics. What you get? You get 1 over 2, k minus 1 over 2 over, oh no, no over, okay, that's it, equal to 0.1. So far so good? If you have the variable with the negative power, what you're gonna do is you're gonna split it under the fraction, okay? If you have x powered by minus a, okay, when you have x powered by minus a, you can flip it under the fraction. You're gonna get 1 over x powered by a. You got it? This is basic mathematics. We're gonna use the same way, okay? So this one, they're gonna get 1 over 2k powered by 1/2 equal to 0.1. 0.1 is 1 over 10, you should know. Then power by 1/2 is square root. It's gonna be 1 over 2 square root of k over 1 over 10. Then they're gonna rearranging the equation. I'm gonna get 10 over 2 equal to square root of k. Square root of k actually equal to 5, right? And then k equal to 25. This is k at the golden rule point, equal to 25. Are you okay with this? Simple mathematics. Okay, k at the golden rule, I write out as a kg equal to 25. Done. In the exam, you have to be able to do this. Any question? Good. Okay, so I can draw in the graph to compare with what we did last time about finding the steady state point. Here, this is k, o, small y, small c, small I, small s, and delta small k. Production function curve, small y equal to square root of k. Delta k, delta is 0.1. What we did before last time is somewhere here. Okay, this is I equal to s square root of k. S is equal to 0.3. This is a steady state point that we find together last time. K at the steady state point equal to 9. Okay, and then y at the steady state point equal to 3. This is y equal to 3. And investment and saving is here, equal to 0.9. Consumption is here, equal to 2.1. This is what we did together last time, okay? I move it to the left because today I'm gonna find you the maximum consumption, okay? The golden rule point. You can see it with your eyes. The maximum consumption is gonna be the place that you have the highest gap between two curves. So maximum consumption should be, let me share to you, orange color should be somewhere here. Biggest gap between two curves, okay? This is maximum consumption. In order to be here, okay, you need to control the investment and saving to be here, golden rule. And you can see that at the golden rule, the investment and saving curve is upper, right? Above. It means that you need to save more. Okay, you need to save more, but we don't know what more it is. Okay, before saving is 0.3 or 30%, but here, if you want to go to the golden rule, you need to shift the investment and saving up, right? You need to save more. If you can save more, you're gonna accumulate more capital from 9 to 25. This is a number that we just calculating over here, 25. We know that if you want to go to the golden rule, you need more capital, right? From 9 to 25. We know here, write down. Okay, if you want to go to the golden rule, you need to accumulate more capital to 25. And from the graph, you need to, if you need to accumulate more capital, you need more investment. If you want more investment, you need to save more, right? You need to increasing the saving rate. So we're gonna calculating together what the saving rate should be. Okay, what is the new saving rate should be? This guy. So here, the old steady state point, if you want to move to the golden rule, okay, from the graph, you can see that we need to accumulate more capital, right? In order to accumulate more capital, you need to invest more. In order to invest more, you need to save more. In order to save more, you need more saving rate, this guy. A very small s should be higher. The question is, what is the new saving rate should be? We're gonna calculate it together. As you know that the golden rule is the best of the steady state point, okay? After we can find that at the golden rule, the capital per worker should be equal to 25. Here, I'm gonna try to find the saving rate. What is the saving rate should be at the golden rule point, okay? So since the golden rule is actually one of the steady state point, so here I'm gonna use the condition of the steady state point. Okay? The condition for the steady state point come up from the capital accumulation equation. So I'm gonna write down capital accumulation equation. Okay, first, this is delta K equal to investment minus delta K. I come up with this one. Okay, I come up with this one. Why I come up with this one? Because from this equation, if you still remember, I equal to S, S equal to SY, and Y in this case equal to square root of K. When I plug it in, it's become delta K equal to S square root of K minus delta. I have saving over here. I can solve the equation to find the saving at the golden rule point, okay? And again, since golden rule is one of the steady state point, we can use the condition of the steady state point. The condition for the steady state point and golden rule is the same, okay? Which is everything is gonna be stop moving, right? Delta K should be equal to 0. Delta K should be equal to 0. Then what I get is 0 equal to S square root of K. K here, I'm gonna use KG minus delta and KG. Okay, I'm gonna put the condition of the golden rule inside the equation. Then I put everything we know inside the equation except saving rate, because saving rate is the one we want to find. I got 0 equal to S square root of 25 minus 0.1 multiplied by 25. This is what I have. And then I got 0 equal to S multiplied by 5 minus 2.5. Rearranging the equation, 2.5 equal to 5S. Okay. S is actually equal to 2.5 over 5. S is actually equal to 0.5. Done. This is S at the golden rule. The saving at the golden rule should be equal to 0.5. You got it? So I just copy this curve, okay? Paste is here. Okay, now I know. Before, your saving is 0.3. Before, people in your country saving 30%, right? If you wanted to go to the golden rule, you need to save more from 0.5, from 0.3 to 0.5. You need to save more. From 30% of your income, okay? Saving more into 50% of your income. So far so good, okay? So after you can find the saving rate, now it's easy. You can find the less, everything that you want. Come back here. At the golden rule point, KG equal to 25, you can find small y. Small y equal to square root of small k. At the golden rule, K equal to 25, square root of 25, y G and the golden rule equal to 5. You can find consumption and saving. Consumption equal to 1 minus saving rate multiplied by Y. The new saving rate, be careful. We use the new one, is 0.5. Y equal to 5. So then equal to 0.5 multiplied by 5. CG equal to 2.5. Done. Okay. Investment equal to saving equal to SY equals to 0.5 multiplied by 5. Investment at the golden rule equal to saving at the golden rule equal to 2.5. Done. Delta K equals to 0.1 multiplied by 25. Delta K at the golden rule equal to 2.5. Done. And then we can double check it. Okay. Delta K equal to investment is 2.5. Delta small k 2.5. Delta K is equal to 0. Confirm that the golden rule point is a point that everything stop moving. Confirms. So far so good. And then the last, just put everything we know here into the graph. The old steady state point, people save 30%, right? Capital at the steady state point equal to 9. People gonna produce, okay, that output per worker, income per worker equal to 3. Investment per worker, saving per worker equal to 0.9. Consumption per worker equal to 2.1. Then if you want to go to the golden rule point, you need to save more. From 30% to 50%. You need to save more. If you save more, you're going to accumulate more capital from 9 to 25. And then you accumulate more capital, you can produce more from 3 to 5. You see that? Output per worker and income per worker become higher or larger. You can see by the yellow highlight. The yellow highlight become taller, right? You accumulate more capital, you can produce more. You earn more money. And then when you earn more money, you can enjoy, save more and invest more. The green area become higher, larger. This is 2.5. And finally, consumption. They use the blue area here. Okay, the consumption also higher. This is 2.5. People are happier than before. Before they can consume only 2.1, right? Right now, they can consume more to 2.5. People become really happy, right? Consume more, get more utility. They are happier. Everyone happier than before. Okay, so what's so good? So golden rule point is a point that you're going to have the maximum consumption. Okay. Any question for here? Okay. Then, next one. Okay, we're going to talk about what? We're going to talk about the transition. Okay. Before we go to the next one, let's set the mind map together, what we already learned so far. We learned many things, right? From the first class. This is class number 4. You learned about capital. What? No. We learned about this chapter is about economic growth, right? You learn about many equations. Remember, we have Y that have 3 main meaning, right? Each meaning have their own equation. Remember, we have production function equation, we have income equation, we have total spending equation, we have consumption equation, we have saving equation. We bring it together in the model. We have capital accumulation equation, right? We have steady state point. This is in the exam, okay? In the exam, you have to be able to calculating the steady state point. You need to calculating everything, put it into the graph and explain. And today we go further, okay? We go further from steady state point. We go further to the best one, the steady state point that can guarantee the maximum consumption, which is called Golden's rule. So you have to be able to calculating and find the Golden's rule point and write it down on the graph. Okay, so this is you have to keep in mind. Okay, so in the exam you need 3 skills. Okay, in this class you need 3 skills. The first skill is drawing the graph. The second skill is about mathematics, and the third skill is about write down explanation. If you have 3 skills, you're gonna be fine. So far so good. Any question? Okay, next one, last one. 2 more pages and then we're done today. Here we're gonna talk about the transition. Transition is like the moving, okay? The moving. If we're gonna move to the Golden's rule point, transition to G, how it's gonna be, okay? This one is gonna be first case number 1. Okay, case number 1 is the country that starting with too low capital. Okay, starting with too low capital, it's like today your country is poor. Okay, have a small number of capital. If you want to go to the Golden's rule, how the transition is going to be. So here I'm going to drawing 2 graphs. Okay, one on the right and one on the left. We're going to see 2 graphs together. On the left is what we did before many times. On the horizontal, it's going to be small k. On the vertical, it will be small y, small c, small I, small s, delta, small k. You have production function. You have delta k. And your country starting with too low capital. Here, investment equal to saving equal to S1 FK. Too low capital starting with here, K steady set point over here. Okay. At the starting point, your country is poor. You have a very small number of capital. On the right hand side, on the horizontal, it's going to be small k. On the vertical, we're gonna want to see the changing of output per worker, consumption per worker, investment per worker, and saving per worker. Just 4 of them. Okay. Y is somewhere here. C is here. Let's say S and I maybe here. If your country stay at the C set point 1 over here, if you're doing nothing, if your country doing nothing, you're gonna stay there forever, because at the C set point everything stop moving, right? At the C set point 1, this is the output that you can produce, Y1. I'm gonna use the yellow color. Okay, the yellow color here. This is the output that you can produce. This is investment and saving, the green, and the blue one is gonna be consumption. Okay, so if you're doing nothing, it's gonna be here forever. You're gonna produce equal to yellow color. You're gonna consume equal to blue color. You're gonna invest and saving equal to green color. It's gonna be here forever, never change. Okay, never change. So for example, here if you stay at C set point 1, Y is like this, stay here forever. Consumption is here, investment and saving is here. It's gonna be horizontal curve on the right because it's not changed. It's not going up, it's not going down, right? Until time T0. Time T0 is a time that your country changing the policy. Okay. On the right is like the changing of time. Oh, I'm sorry, this is wrong. On the horizontal is not small k. On the horizontal is time. Okay. So you see that before T0, you didn't change anything. Y still the same. C still the same. Investment and savings still the same. Horizontal curve, right? You didn't do anything. You stay at the C-set point. Nothing changed. You just stay there. Okay. However, at time T0, your country decide to change the policy. Your country decide to change the policy. In this case, your country is starting with a very small capital, low capital. If you go to the golden rule, in this case, if you want to go to the golden rule is a point that you have maximum consumption. Remember, the maximum consumption. Where is it? Where is it? Where is the maximum consumption? You can see it with your eye. It should be somewhere here, right? The highest gap between two curves, right? Consumption is actually on the right, okay, on the right. So if your country want to go to the golden rule point, you need to change something. You need to change the policy. How you going to do? The golden rule point, the maximum consumption is on the right. If you want to go to the golden rule, how you going to do? You need to, what you need to do? Again. That's really good. You need to accumulate more capital. You need to go to the right, right? How to accumulate more capital? You need to save more, right? Okay, so you need to do something about the saving rate. I'm gonna put here the yellow. Oh no, not this one. Yeah, I'm gonna put the yellow color here. You need to change the saving, right? You need to save more. So what I'm gonna do is I'm gonna change to the red color. I need to save more like this. S1 to S2 FK. Save more. If I save more, saving and investment curve gonna shift up. Then I'm gonna accumulate more capital. C-set point moving up to the right to the golden rule point G. When we save more, we invest more. We're gonna accumulate more capital. KWS going to the right to KG, right? And then the right graph, we want to see how Y gonna change, how C gonna change, how S and I gonna change. Starting with Y, when you accumulate more capital, Y, the variable Y, I'm gonna use the yellow color. Y output per worker gonna be keep increasing to the right. You see that? It's a curve. The yellow highlight keep increasing to the right. You accumulate more capital, output per worker will keep increasing up to the right. So write it down on the right graph. Time T0, you change the policy. You convince people to save more, okay? Then you accumulate more capital, you can produce more. This is a smooth upper curve going up like this. This is a yellow color. Everyone okay? This is just small y, right? How about C, consumption? Focus on the blue area, okay? The blue area. When you save more, saving curve shift up. The blue area become shrinking, smaller, right? Because when you save more, you need to sacrifice your consumption, right? Day one at time T0, when everyone save more, the gaps become smaller, shrinking, okay? Let me write it down here. Day one is become smaller. You got it? The blue highlight area become shrinking, smaller. And then when your country accumulate more capital moving to the right, the area of the consumption going to become larger until going to the maximum consumption. Day two, day three, you see that? Larger until going to the maximum consumption. So what this means is you need to sacrifice some consumption in the first day. The consumption curve gonna shift down, you see, jump down, okay, the first day, and then after that, it's gonna keep increasing until it's higher than before. So good? They have a jump down and then going up. Okay, it's different from Y. Y is smoothly increasing. Consumption, they have jump down and increasing after that. Okay. How saving and investment? The green area is very small. After everyone save more, saving increasing, the investment and saving curve shift up, right? The green area become increasing a lot, expanding, okay? Green area, day one, increasing a lot, and then keep increasing a little bit more. Okay, so for investment and saving. Let me share this one a little bit. Investment and saving. At day one, it jump up and keep increasing. Okay, this is the green color. So far so good. Okay, this one they have jump up and keep increasing. This is the transition, the changing of small y, small c, small s, and small I over time if the government change the policy. So far so good? Good, good. Any question? Okay, then last one, opposite case. Okay, still the same. The transition to the golden blue point. This is case 2. Okay, starting with too low capital. Oh, no, this is too high. Sorry. This is the opposite case. Starting with too high capital. Okay, again, drawing two graphs. One on the left and one on the right. Not so good. Okay, and then your country is here. This is I equal to S equal to SFK S1. C, this point is here. This is 1. You have too much of the capital. This is your output. Okay. Y SS1. This is your output, the yellow color, output per worker. The green color is wait, let me switch it. This is output per worker. This is the green color is investment and saving per worker. Consumption is the blue color. This is the case of your country have too much of the capital. When you have too much of the capital, what does it mean? It means that your country need to invest a lot. Your country need to save a lot, and you need to sacrifice your consumption. That's why consumption is small. You see that? Consumption is very small, the blue color, okay? If your country doing nothing, your country is gonna be here forever because at the season point, everything stop moving, okay? If you didn't do anything, you're gonna be here forever. So you're gonna write down the information into the right graph. 0, time, okay? This is Y, C, I, and S. Y, for example, here. This is time T0, okay? Then you have C, you have I and S. Okay, if you're doing nothing, Y is going to be stable. Consumption is going to be stable. Investment and saving is going to be stable. Never change, never going up, never going down. If you didn't change anything. However, until one day, time T0, your country decide to change the policy. At time T0, your country decide to change the policy. You don't want to be here anymore. You just found out that this is not a good point for the people because people consume are very small, right? People are not happy at all. If you want to make people to be happy, you need to give the maximum consumption to the people, right? Okay, the maximum consumption, you can see it with your eyes. Where is the maximum consumption? If you see it with your eyes, maximum consumption should be somewhere here, right? Bigger gaps between two curves. It's on the left. If you want your country to moving to the golden slough point, how it's gonna be? You just need to save less, okay? Save less. If you save less, saving and investment curve gonna shift down. It's like S2FK. If you save less, see this point gonna moving down to the golden slough point. This is like KG. You need to save less, invest less, and how to say, lower the number of the capital. Okay, lower the number of the capital. The capital moving to the left. If the number of the capital become lower, it means that we're gonna produce less. Okay, the yellow color, we're gonna produce less. Y become lower, moving to the left. Okay, lower over time. So it's gonna be like this for Y, become smooth lower over time. This is for the yellow color. So far so good. Okay. How about consumption? Consumption. When you decide to save less, everyone in the country decide to save less. The gaps, okay, the gaps become bigger for the blue color. Okay, become bigger. See that? Before you consume very small, right? But right now you decide to save less, you can consume more. Consumption become bigger, and then moving to the left, a little bit smaller over time. Okay, so for the consumption, the curve is gonna jump up like this and lower a little bit over time. Okay. How about investment and saving? Before you save a lot, invest a lot, the green color. After you decide to save less, saving curve shift down, saving and investment gap become smaller, shrinking. This is a green color. Shrinking down and going to the left like this. So the curve is gonna be like this, shrinking down and lower a little bit. This is a green color. So far so good. Okay, this is what we have. This is a transition, okay, the moving of the whole economy. When you have, you're starting with, you have too much of the capital. Everything good. This one I forget to write down here. G, okay, the less is good. Okay, so here, all for today, done. Any question? Yes. At the golden slough point, consumption always maximum. No, not really. Consumption at the golden slough point may not equal to saving. Can be greater than, can be less than, depend on the mathematics. It's not always equal to saving, no. Can be greater or can be less than. It's not guaranteed. Okay. And after you stay at the golden slough point, if you're doing nothing, you didn't change anything, you're gonna be there forever by the theory. Okay, because at the golden slough point, delta K equal to 0, nothing changed. Until some parameter change. If some parameter change, the golden slough point may be changed. Okay. So far so good. So you can see that in the theory, things just depend on three graph, three curve: production function curve, investment and saving curve, and capital depreciation curve. Everything depends on three curves. If some of these change, everything is going to change. If it's not changed, you're gonna stay there forever. If you already be at the C set point or the golden rule. Okay. Any question? Okay, no question. Before we go, next class is gonna be on Monday, right? The Monday is like the national holiday. However, I still gonna give you a lecture, but not here because the university closed, right? So next Monday, I'm gonna give you the online class by Zoom, okay? We still have a class because I want to finish everything before New Year. Okay, so we're gonna keep having the class as a regular, okay, as normal. But next Monday, not here in the Zoom program, okay? Got it? If you are busy, you travel with your family, that is okay. You don't need to come online. You just watch the video clip later, okay? That's it. See you on Monday. Bye-bye.